Hello, children, students, teachers, and all parents and all the stakeholders. Welcome to Class 8 Mathematics. This is yours, Kona Kiran Reddy. In my previous videos, I explained all the problems of exercises from some chapters like chapter 1, chapter 2, chapter 4, chapter 5, chapter 6, all those. Now I started chapter 7. If you want to see my previous videos, here in the description I am giving the links of those playlists. Please go through them and share them so that the others also can make use of them. And if you like my videos, please subscribe my channel. Okay. Now let us quickly go through exercise 7.1, third problem. Find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. Here we are given some numbers. These numbers are not perfect cubes. To make them perfect cubes, with which we need to divide these numbers, that is what we need to find out. Let me take one example here. Suppose if you take 16, 16 can be written as 2 into 2 into 2 into 2. So here to get a perfect cube, we need triplets of equal numbers. So here 2 into 2 into 2, we have one triplet. Additionally, we have one more t. This is excess actually. So we need to remove this 2. To remove this extra 2, what we do? Just divide 16 by that extra 2. So 16 divided by 2 gives us, this is equal to, 16 is 2 times 2 times 2 times 2 divided by 2. So that 2 and 2 gets cancelled. We get a triplet of 2's. So that it becomes a perfect cube. Here in this case, we divided 16 by 2 to get a perfect cube. In the same way, we can do all the given problems. Now, let us take the first one. What is that? 81. First, let us resolve this into factors. Let us divide 81 into prime factors actually. So, let us do prime factorization. 81. So, it will not be divided by 2 as we have 1 in the units digit. So, let us start with 3. So, 3 times 2 is 6. 8 minus 6 means 2. 21 will be there. So, 3 times 9 is, so 3 times 7 is 21. Now, start with 3. 3 times 9. Then again 3. 3 times 3. So, now therefore, 81 can be written as 3 times 3 times 3 times 3. So, here 3 times 3 times 3. This is a triplet of 3's. Now, here 1 3 is extra. So, if we remove this 3, we can get a perfect cube. So, therefore, 81 is to be divided by 3 to get a perfect cube. That's it. Let us go to the second problem. In the second problem, what we have, that is 128. Now let us resolve 128 into factors. Start with 2. 2 times 6 is 12, then 2 times 4. Then 2 times 3 and 2 times 2. Then 2 times 1 is 2, 1 will be there, 12 means 2 times 6. Then it is very easy, 2 times 8 and 2 times 4 and 2 times 2. Now therefore 128 can be written as, how many 2's are there? 1, 2, 3, 4, 5, 6, 7 2's are there. So 1, 2, 3, 4, 5, 6, 7. Now here observe the triplets. 2 times 2 times 2 is one triplet and 2 times 2 times 2 is another triplet. Here observe 1 2 is extra. We need triplets, but here we have 1 2 extra. If we remove this 2, then it becomes a perfect cube. Why? Because if you remove this 2, triplets of equal numbers will be remained. So therefore 128 is to be divided by 2 to get a perfect cube. That's it. Now let's move on to the third one. Third problem is 135. So now let us resolve this into prime factors. So 135, this is not, first start with the 2. This is not divisible by 2. Why? Because we have 5 in the units digit. So let us start with the 3. Before starting with the 3, let us check whether 135 is divisible by 3 or not. How to check? Add the digits. So 1 plus 3 plus 5, that is equal to 1 plus 3 is 4. 4 plus 5 is 9. So 9 is divisible by 3. So 135 is also divisible by 3. So 3 times 4 is 12. 1 will be there 15. 15 means 3 times 5. Now again start with 3. 3 times 1 is 3 and then 15. 3 times 5. Then again start with the 3. 3 times 5 is 15. So we can write therefore 135 equal to 3 times 3 times 3 times 5. Now observe the triplets. 3 times 3 times 3 is one triplet, but additionally we have times 5. So this is extra. So we need to remove this extra 5 to get a perfect cube. To remove this 5, what we need to do? Divide 135 by 5. So that this 5 will be removed and 3 into 3 into 3 will be remained, and that will be a perfect cube. So 135 is to be divided by this extra 5 to get a perfect cube. So therefore 135 is to be divided by 5 to get a perfect cube. That's it. Let us go to the fourth problem. So what is fourth problem? You see here 192. Fourth problem 192. Now let us resolve. Let us divide this into prime factors. So 192 we have. Start with 2. So 2 times 9 is 18. 1 will be there 12 means 2 times 6 is 12. Then again start with 2. 2 times 4 is 8. 1 will be there 16 means 2 times 8. Then 2 times 2, then 2 times 4. Then 2 times 1 and 2 times 2. Then 2 times 6. Then 2 times 3. Now write 192 equal to, how many 2's are there? 1, 2, 3, 4, 5, 6 2's are there. 2 into 2 into 2 into 2 into 2 into 2. Then we have 3 here. So into 3. Now observe the triplets. 2 times 2 times 2 is one triplet. Then again 2 times 2 times 2 is one more triplet. So we have additionally we have one extra 3. So we need to remove this 3 so that the remaining number becomes a perfect cube. For that what we need to do? If we divide 192 by 3, then this 3 will be removed. So therefore 192 is to be divided by 3 so that it becomes a perfect cube. So to obtain a perfect cube. That's it. Now let us go to the fifth problem. Fifth problem is 704. Let us resolve that into prime factors. So 704, resolve this into prime factors. Divide this into prime factors. So first start with 2. 2 times 3 is 6. 1 will be there 10. So 2 times 5, then 2 times 2. Then 2 times 1 is 2. 1 will be there 15. 2 times 7 is 14. 1 will be there 12. 2 times 6 is 12. Then 2 times 8 is 16. 1 will be there again. 2 times 8 is 16. So then 2 times 4, 2 times 4. Then 2 times 2, 2 times 2. Then 2 times 1 and 2 times 1. That means 2 times 11. That's it. So therefore 704 equal to 1, 2, 3, 4, 5, 6. So 2 times 2 times 2 times 2 times 2 times 2 times 11. So here observe the triplets. 2 times 2 times 2 is one triplet. Again 2 times 2 times 2 is another triplet. So we have additionally we have one extra 11. If we remove this 11, the remaining number will be in the form of triplets, so that it becomes a perfect cube. So to obtain a perfect cube, we need to divide this 704 by this extra 11. So therefore 704 is to be divided by 11 to obtain a perfect cube. That's it. Now let us move on to the next problem. So exercise 7.1, fourth problem. Parikshit makes a cuboid of plasticine of sides 5 cm, 2 cm, 5 cm. How many such cuboids will he need to form a cube? To form a cube, the given numbers must be in the form of a cube. That's it. That is simple reasoning. We need to form a cube. That means the given numbers must also be in the form of cubes. Right. So the given numbers are, what are the given numbers? Given given dimensions equal to 5 centimeter, 2 centimeter, comma 5 centimeter. To get cube, these numbers must be in the form of cubes. So 5 centimeter times 2 centimeter times 5 centimeter. This is equal to, simply avoid centimeters. So 5 times 5, then times 2. So here observe the triplets. Actually there are no triplets. So 5 times 5 is there. If you multiply this with 5, then it becomes a perfect cube. Here also 2 is here. Now we need to multiply this with 2 times 2, so that we will get 2 into 2 into 2 here. So it will be in the form of a cube. So therefore 5 times 2 times 2. So here this is equal to 5 times 2 is 10. 10 times 2 is how much? 20. So therefore needed cuboids equal to how many? 20. Okay children, so 20 is the answer in this case. Hope you understand this. If you understand or if you like my explanation, please like, share and comment, and before that, please don't forget to subscribe my channel. Thank you. Thank you one and all. Yours Kona Kiran Reddy.